start, do you guys have any idea what is Kubernetes and why there is a need of Kubernetes? First of all, Anurag, do you have any idea about Kubernetes?
I understand that it is used for orchestration of multiple containers, which Docker itself cannot achieve. And when the scale is larger, we need some tool to manage all of these containers.
Okay. And Rajeshri, any idea?
Yeah, I guess like Kubernetes the container architecture engine, which is basically for the high availability of the containers and the tolerance of the containers, which other orchestration engines can't able to manage.
Okay. Vinay and Adarsh, any idea? Okay. So before we start the yes, yes,
It's a
Adarsh.
open source system,
Okay.
uh, so which is used for automating deployments and scaling as well.
Okay. So, like, your answers are correct. Like, before we directly jump to Kubernetes, let's go back again to the monolithic and microservice architecture. Do you guys remember we talked about the monolithic and microservice architecture? In monolithic, we have one server and application is directly deployed on that server, right? And multiple components of the application are deployed on the one server. And if the server goes down, the whole application goes down, right? That was the monolithic architecture. Then we jump to the microservice architecture where we have multiple server serving same application. Okay, serving same application and multiple components are there like front end, back end, or database, any kind of like separation of the application. Sometimes one only application has multiple paths. Okay, multiple paths means multiple APIs, multiple backend. So yeah, it depends on the application to application. So in microservice, we started working with the we just deployed application on multiple servers so that we can achieve the high availability. And if one server is down or one component is down, that will not impact the other component. So this was the microservice architecture. Now we also talked about the Docker. Docker has the facility to provide the microservice, and Docker we use Docker in the microservice architecture, right? Apart from Docker, the major component is that container. Docker is a tool which provides the service of containerization or which provides the facility of containerization. We also have more tools in the market for the same concept, but Docker is the most popular from them. Now in Docker, we just use the Docker file, and through that Docker file, we just created images and we deployed that images by just using the Docker run command. We also have a tool in Docker which is known as Docker Compose. Okay. Now, what Docker Compose does, you can define multiple images, you can launch multiple containers using one YAML file. Again, YAML. Okay. So through the Docker Compose. So if you want to deploy three containers, if you want to deploy three containers together and you want to set up networking, in that case, Docker Compose can help you. By just one file, you can just have to fire one command and it will create the infra for you. If it will create the setup for you, not the infra in Docker Compose. Okay, it's a very easy tool. You guys can check out the Docker official documentation for this Docker Compose. It's very easy to understand YAML. The same thing that we did with the Docker run command, you will be just have to define the container structure over there and the basic networking structure and also the flow. Like for example, we have these three containers. Which container should up first? Because sometimes sequence also matters. If you guys don't know why sequence matters, for example, this app depends on this app. Let me give the name here, app 2, or let me give the app 1 here, app 2, and app 3. So, for example, this is the sequence. Okay. Now, app 1, app 2 depends on app 1, means app 1 should be up first, then app 2 will work. So in app 2, there is a URL which is mentioned. Like if the URL says 200, if URL gives the status code of 200, only then app 2 will be up or will be running. So similarly, app 2 is the dependency of app 3. So if app 1a, sorry, let me delete this. So the flow will work like, first of all, we need to up the app 1, After that, we need to have the app 2. Then in the ending, the app 3 should run. So if we want to achieve this flow, again, we have to use the Docker Compose. First of all, we need to mention this app container, then this, then this. So it will be working sequentially. So the sequence depends on the programmer, like depending on the code, how it is written, or the component. For example, your component is Nginx. Okay. And in this Nginx component, you have done the load balancing or you have done the path-based routing. Now, in the path-based routing, the paths are mentioned, and in the paths, you have the IP addresses. For example, this container is the Nginx container. Now, if you up this third container in the beginning, you don't have the IP addresses of other two containers, what will happen? You will face the error. Why? Because these containers are down, or the name of these container will not come. These containers are down. So this third container will not work. So what is the important? What is important? First of all, the container one should be up, then container two. In the ending, the Nginx will be up and there will be no errors. This is how the flow or sequence works. You can mention the whole flow in the Docker Compose file. But remember, what we are doing here, we are launching all the containers in one server. Remember that. Even if it is microservice, we are doing this concept on a one server. The server is a one server. The components are different. Now, because the components are different, if one component is down, that will not impact the another component. Okay, that will not impact the another, because here we have the sequence. If app 3 is down, no impact will be on app 2. If app 2 is down, there will be impact on app 3, but not on app 1. App 1 will be working fine. Okay, so everything depends on the dependency structure. But if everything is launched without containers directly on a one server, if one application is down, it may take every application down. Because as you guys know, in containers, we have complete separate isolated environment, right? So this is how the microservice architecture works. Now here we were launching whole application in one server, right? So it's a good architecture, no issues on that. But what if we have to launch 100 components of application and every component should be replicated 3 times? That means we have to launch 300 containers. Now, if we launch 300 containers in this one server, what do you think? You guys can manage those 300 containers, the networking of those containers, and the structure of those containers. Remember that we have to do the third three replication of those containers. Why replication? You remember the autoscaling groups, right? When we have the replica of one server, whenever one server is down, the other two server will be serving the app. That's why replication of every application. So we should not have any downtime. Now, if we want,
Autoscaling can work on the Docker as well, or it's on the base server on which
no,
the
no, no.
Docker is there.
When we talk about the autoscaling ASG autoscaling groups, that's only for the AWS, right? It's not
Right.
for the Docker. Now, here in Docker, we don't have any concept of autoscaling.
Okay.
So here, as we can see, Docker cannot work. Okay, and managing 300 containers directly from one server, you guys can never imagine. If you are doing Docker PS command, you have a list huge number of servers. How you will be managing 300 servers? For example, if server number 79 is down, how you would be fixing that server of a container? How you would be fixing that container if sorry, container number 79 is down? You have to go inside the container, debug that, and again make it up. Or you have to remove that 79 number container and you have to run another container on that place. It will be very difficult to manage when the number of container is very high, right? So in this situation, we have to use a tool which should work as an orchestrator over this container structure. So now here comes the concept of Kubernetes, and we call it as K8S in short. Kubernetes. Now, when it comes to Kubernetes is a very, you can say, smart architecture. It's not a one system or one tool, it's an architecture. In Kubernetes, we have multiple components. Okay, so the first term that we are going to see in Kubernetes, or we are going to talk about in Kubernetes, is cluster. Do you guys have any idea about cluster? Anyone?
Is it a collection of all the Docker
No,
containers?
no, no, no. We are not talking about
It's a
Docker right now.
yeah, it's the collection of nodes actually, different
Exactly.
nodes. You
Cluster means the connection of servers. They can be physical servers or virtual machines, or no, we call them basically nodes. So this is called a cluster where you have three machines. I'm not talking about containers. I'm talking about servers. We have three, four servers here. So this is called a cluster. And all the servers will be connected to each other basically because it's a group of cluster, group of servers. That's why it's a cluster. Okay. Now cluster structure can be like we may have multiple nodes, like 3 nodes, 5 nodes, 10 nodes as per a requirement. Okay, so in Kubernetes we basically follow the cluster architecture. We have a cluster, and in this cluster there is a concept of master and slave, or you can say master and worker node. Every server in a cluster is called a node. Okay, so the master, we have a master node and we have few worker nodes. So you can understand this cluster architecture like this. So this is the master and these are the slaves or worker. Okay, all three are the nodes. Now these worker nodes are connected to the master, by the way. The networking is already done here. So master is basically nothing but it's the brain of the cluster, which will send the instructions. Okay, so master is the brain of the cluster, which will send the instructions to these nodes. This is how a cluster looks like. Now, in Kubernetes, we may have multiple masters as well. Why? Because if one master is down, what will happen? The whole cluster will be down because master is very important, right? So we may have two masters in this concept. We may have two masters, and both masters may be replicated or connected to each other, completely replicated for high availability. And when it comes to node, all the nodes will be connected to these masters. So the second master is known as co-master, or you can say replication of master. So co-master, replication of master. For example, due to some issue, if this node is down, this co-master will turn into the master and there will be no downtime. So our major motive of using Kubernetes is that we should not face any downtime. High availability is the motive in Kubernetes architecture. Okay, so this is how a cluster looks like. Now you guys must be wondering, like these are the empty servers, right? I haven't talked about any component yet. This is just a cluster structure. Now every system has a specific configuration, right? Some CPU, RAM, and CPU. What do you guys think? Like for example, the worker node has the 8 gigabytes of RAM and 8 core CPU. Every worker node has this. What should be the configuration of master according to you? Tell me. Higher than that or same? Like definitely not same. Higher or lower? What do you think?
I think lower should be fine because its job is not to do what the worker does. It's only to manage the workers, right?
Exactly. So the configuration of master is lower than the worker. The reason is that because master is never going to do the work, the hard work. The hard work will be done by the worker nodes. Master is just to manage the nodes. Okay. Even it can be same, but usually we keep it low to save the cost as well. Now, when it comes to the internal architecture, first of all, this is the cluster structure. I guess you guys got the cluster idea of cluster, what is a cluster and how it looks like. Okay. Now let's talk about the architecture of Kubernetes. So I have an image for that, and here it is, the Kubernetes image. So basically, this is the Kubernetes architecture. Here we have one Kubernetes master, and here we have one worker node. Okay, let me check if I can pick this image and paste it here. Yes, I can do that. Okay, so here we have one master and two worker nodes, right? Now, if we talk about the master node, here in master we have four components, And in worker, as you can see, we have basically one, two, three, and four components again. Okay, let's don't consider this as a component. Just remove this as the component. We have three components in workers and we have four components in master. Let's talk about these components first. Okay, first of all, when we talk about the Kubernetes, the smallest unit of Kubernetes is not a container. In Docker concept, the smallest unit is container, but in Kubernetes, the smallest unit is a pod. Okay, a pod. Now you guys must be wondering what is a pod. Pod is again an environment, isolated environment. In a pod, a container is launched. So the containers are launched inside the pods. Okay, so that's why we have multiple nodes, pods in every worker node. Now, by default, like by not by default, it is recommended that you should launch one pod container in one pod. You can launch multiple containers in one pod, but it is suggested like you should launch one container in one pod. Why? Because if this one container is down, one pod is down, a new pod will come up automatically because the Kubernetes has the auto healing facility or auto healing feature, and the only container which was dead will come up again. So pod again, the pod is nothing but it's the isolated environment, similar environment that we saw in the Docker, okay, in the container. But here the pod is the smallest unit. In the pod you have the container. Now you guys must be wondering why we have the concept of pod, why we are not directly working on the containers. The reason is that the Kubernetes can control the pods only, not the containers directly. The Kubernetes sends the command or the instructions to the pods, then pod manages that container. That's why pod is the smallest unit, not the container. Okay. And you can launch, again, remember, you can launch multiple containers in one pod, but this is not recommended. Always launch one container in one pod. Okay. So you will take the benefit of auto healing efficiently. Now, when it comes to the worker, as you can see, the pods are launched in the worker, and then these pods, the application is launched inside the container. Okay, like these pods. Here we have three containers, two containers, and one container in one pod. So in the workers, we also have one more thing. Now, this is a Docker, right? Docker is installed in the worker node. Now, this Docker is also known as container engine. Why container engine? Because of this Docker, the containers are running inside the pods. Okay. So remember that pods are not persistent. If the pod is deleted, inside the data inside the pod will also be deleted. So for that, we have to mount volumes. That's a separate concept. Like by default, pods are not persistent. If the pod is deleted, data inside the pod is also deleted. It's a completely separate environment. And Docker engine is the program or is the tool which is installed in this worker node so that a container can be launched inside this pod. After this, we have two more components here, kubeproxy and kubelet. Let's talk about kubeproxy first. We talked about this cluster architecture, right? Where we have multiple worker nodes. And every worker node communicates to each other to get the information. Now, this communication should be done by any network, and that network component, which helps in the communication between the nodes, that component is kubeproxy. As the name says, proxy, it's a component which helps us to communicate, set up a communication between the nodes. Okay. After that, in the ending, we have kubelet. Kubelet is responsible to perform the task on the nodes. Okay. Every command to the node will be sent through the kubelet. Now, kubelet will provide the instruction to the node to perform the task. Okay. So, any doubts in the workers node section? Anyone?
No.
Okay. So, this is how a worker node looks like. We have three main components in it, and every pod will be long.
Yes.
Yes, yes.
Sorry. Yes. Yeah. I want to know about Cube proxy. What's the role of Cube proxy in worker
Okay.
node?
Do you know
Yeah.
what is the working of a proxy server? Why we have proxy servers?
Uh, yeah, I know. Like proxy, we used to, for instead of the original server, we used to
No, the
connect to.
this is just a myth, like to mask the IP address. This is just a myth. The use of proxy is can be dividing load as well, or transferring load. Path-based routing, dividing load, everything can be done through the proxy. I told about the Nginx, right? Nginx as the for using the as the path-based routing. So Nginx is a proxy server basically. It's nothing but it's a proxy. So you can understand it like this. This is a client. Client is sending request and request is going to all these three servers. Client is sending request to one server only. Now client doesn't know where this request should be sent, like directly to on which server, but this proxy knows. This is the proxy who is sending the request to the servers. This proxy can be understood as the load balancer. Load balancers are also proxies. So in the ending, you are going to, whenever you're going to do the ping or the telnet or NS lookup to any IP address, any application which is deployed on AWS, by with using the load balancer, you will get the IP address of the load balancer only. You will not get the IP address of these servers. For that, you have to go dig more, right? So this is how proxy works. Now, similarly, this kube proxy is responsible for the communication between these two nodes because these nodes communicate with each other as well as these nodes are communicating to the master. So it's for the internal communication or internal network. You got it?
I got.
Okay. Now, in the ending, we have kubelet. Kubelet is a component which actually communicates, provide the task to the nodes. This component actually launches the containers, pods, and containers inside the pod. So for a worker node, this is the master. Kubelet is going to give the command to the inside the node, not outside the node, only for that particular node. So every node has its own kubelet, not for the master, only for the worker. Every worker node has its kubelet, which does the work of the master. And also kubelet sends the information to the master from the worker. Information means like this port is dead, this health of the node is not good, the node space is full, these kind of information. The kubelet sends those information to the master. Got it? So this is how a worker node works. Now let's talk about the master node. Now master is the main component. It's a brain of the cluster. Now in the master we have four components. Number one component is API server. Now do you guys have any idea about the API servers? We talked about the API, right? Any idea about API server? Okay, let me tell you. Why we need a server here is because how you would interact with the cluster, first of all. The way to the interact with the cluster is that API server. Now, API server will create a URL for you, okay? And in that URL, for example, like mykts.com, I'm just taking the example, don't take this seriously. It's just a name, the name is just an example. Okay, for example, this is the API server. Now, if I want to launch the pod of any application, I will be sending request to this API server along with the information, the data that will be I will provide. And this API server works as the actual, you can say, controller. This API server will send the request to the scheduler, right? And this scheduler will assign the task to this kubelet. Like this pod should be launched here, for example, and the pod will be launched in that particular node. So API server takes the request from the user interface or the client. Now, basically, user directly don't interact with the API server. We use a tool called kubectl. Kubectl is a tool which is a command line tool. You send the command to the kubectl, like I want to list the pods. The command will be send it to the API server, and API server will send that command. Like I am sending a command to list the pods. How many pods are there? The API server will send the command to the this time the command will be sent it to the etcd. I will talk about etcd later, and you will get the output directly. Okay. Now, kubectl is the interface or is the command line tool that you use to communicate with the cluster. And kubectl sends command to the API server. So this is the important thing which communicates with the API server. Okay, I will talk about
So,
this.
yeah, so API server is the gateway of Kubernetes, we
Exactly,
can say.
it's the
Like
gateway.
we
It's
can
the gateway.
yeah.
Exactly, it's the gateway of Kubernetes cluster. You can say by Kubernetes API server, you can communicate to the whole cluster, and it also creates the communication between the cluster structure. Okay. Now, after this API server, we have a scheduler. Now, the working of scheduler is to schedule the pods, as the name suggests. Now, scheduling pods is also a heavy task. Why? For example, this node has 30% space available, or you can say 20% space available. Only 20% space available in this node. And this node has the 60% space available. Now scheduler will see, like if I want to launch the pod here or here. So scheduler will decide the pod should be launched here because we have more space available here, right? The pod can be launched on any server. Basically, we have few rules to define, like stateful sets and labels, lots of thing is there. But according to our use, for example, by default, it will see 60% available here. Let's launch the pod here because this worker node doesn't have that much space available. So the pod will be launched here. I mean, scheduler will send the command to the kubelet. Scheduler will not launch the pod. It will send the command to the kubelet. The kubelet will launch the pod. So again, kubectl to API server, API server to scheduler, scheduler to this kubelet. This is how it works. Now, when we talk about the controller manager is basically, you can say, a component which actually manages the working of these nodes. Now, what's going on these nodes, the information, everything comes to the controller manager from the kubelet. The health and that kind of stuff comes to the controller manager, and then controller manager sends the information to the etcd. And when we talk about the etcd, it's a database. It's nothing but it's a database which stores the data in the form of key value. Now, reason why it stores in the form of key value, because we are talking about the API server, right? So to make it more easy, first of all, key value comes under this non-relational database system. Oh, sorry, NoSQL. Basically, it's not a SQL database. Structured query language is not there. It's a NoSQL database structure, and it's very easy to perform the read operation in key value database. If I want to search anything, I just have to give the key. That's it. You will get the exact value. But when we come talk about the structured query language, SQL or SQL, in that case, we have to perform lots of search operations to get the data. So if this key value pair was not there, if there is a structured query language or a SQL database, it will take too much time to process the data. So for the faster response, we have a queue value structure here in the form of database in the etcd. So it stores every information, how many pods are running, the health of the pods, what's going on with the cluster, space, everything is mentioned in this etcd. So it's a, you can say, storage area for this master. Okay. And if you have one more master, same components will be replicated to that master, same components. Okay. And it's basically for the DR situation, disaster recovery situation, where there is a master is down, the cluster is not working properly due to master is down. There will be a backup server which will work as the master when this master is down. Also, we sometimes we do the failovers. Failovers means, like for example, this master server need to be rebooted. Now you cannot reboot the master because it's communicating with these nodes and continuously communicating with these nodes. If you reboot this master, whole cluster will be down, application will be stopped. So you should have another master. Then you will create that main master or the master, and you will remove this from the cluster, this master from the cluster, and you will be doing the reboot. So these are the best practices. You cannot take the reboot of a production system directly. You should have a backup before that. Okay. So this is how the Kubernetes architecture looks like. If you guys have any doubts, you can ask.
Yeah, Manish, I have one doubt, like not doubt, because recently I faced one question
Okay.
regarding what is the Kubernetes architecture and what their task like. As I described, API server, scheduler, control manager, and etc. But the guy is asking me like from where API server, scheduler, and control manager used to get data, like what they will perform, right? Like API server, how he used to send scheduler, and how scheduler used to decide like where his scheduler used to get the data that where he will create a pod. So
Okay.
I told it should be etcd because etcd used to store the metadata.
Exactly.
Then again he is asking me from where etcd is getting the data.
Using kubelet, like controller manager is taking data from the kubelet and it's sending data to the etcd. Controller manager.
So it's-
Yes.
so what should be the answer? Like it is from where etcd is getting that? It's from kubelet from worker node.
etc controller manager is taking data from kubelet and then giving it to the etcd. Etcd will not do anything. Etcd is a database only. It cannot do any operation. It can just give the data or take the data. That's it. So controller manager is there to take the information from the server, the worker nodes, and then it will give it to the
Well, so
etcd.
okay. So etcd used to get data from control manager, right?
Exactly.
Okay. So from where control manager used to get data from
Kubelet.
kubelet in the worker node, right?
Exactly.
Okay. Okay. Yeah. Thank you.
And it also, like for example, there is a pod which should be which is dead. For example, this pod is dead, right? So pod will send the information to scheduler that this pod is getting dead. Along with that, the scheduler will ask the kubelet to launch the pod. Okay. So if there is any mess with the worker node, the controller sends the information to scheduler. So controller works as the, you can say, the person who is sending information from here to there. Okay, it's taking information from the worker nodes. For example, this pod is down. The information, the controller will get the information from the node and will send it to the scheduler, and scheduler will say that let's replace the pod, and again scheduler will send the information to kubelet to replace the pod. Okay, so this is how it works. You got it?
Yes, I got
So
it.
yeah, there's a multiple roles of these components. But yeah, when it comes to etcd is just for read and write operation. It's just a database. That's it.
I have one more question. Just want to know the idea. Like, what is the stateful server and stateless server? Like, yeah.
Stateful server, let me symbolize this for you. For example, you are going to launch a database. Okay. Now, what is a database? Let's talk about the database first. Database is, you can say, an application or a program which actually stores the data. It can be a SQL database or NoSQL database. Now, for example, if you launch the database inside this Kubernetes cluster, what will happen? Due to some issue, if you have launched the database as a container, and due to some issue, sorry, as a pod, and in that pod there is a container. In that container there is database. Due to some issue, this pod gets down. What will happen? Database is not there for that particular second or microsecond. In that microsecond, your application will face issues because the work of application is to communicate with the database and give the take the data, insert the data, perform read and write operations to the database, right? And if the database is down, like for example, the pod is getting rescheduled, what will happen? The application will face the issue. In this situation, the stateful set comes here. Like for example, we set up the application like this that there should be no downtime. We should have the backup of databases or replica of databases to serve in that particular time. Most of the cases, what we do when it is come to the database, we never deploy the database on the Kubernetes. In my organization, we never do that because it's a very risky part. If you are setting up the database on Kubernetes, it can down anytime, and if you should have the backup for that. So, like replica should be over there, but still, it's a risky to deploy the database on a Kubernetes worker node. We always keep database completely separated for this. So here the stateful set concept comes, where the database will not get down. It will be keep working. There will be no downtime. Okay, you got it?
Yes. Like we can say the database container will be the stateful, like database node will be the
Yeah,
stateful server.
this is the situation where we will require this stateful concept so that the database could not get down. Like we should not face the downtime.
Okay.
Okay. Any other doubts?
Okay. Yeah. So what is the stateless, like web server is will be the example?
Yes, you can say
Like
that the no, no, like these stateful and stateless are the features in the Kubernetes that you can apply. Like web servers are just normal. Like whenever a pod is gets down, web server pod, another pod comes up, and in that microsecond, you will never see the downtime because it's not about the data. As well as in the database, the data queries are keep running. If the database gets down, a new database will come up. The queries will be refreshed, right? So that's also a difficult situation, right?
yeah.
So that's how it works. Now let's talk about the any doubt?
Oops. Hey Manish.
Yes, Adarsh.
So, what happens if node, stop working?
Worker node stopped working.
Yeah.
You are talking about the disaster, I
I
guess.
mean, here the controller manager is used to control the nodes, right? So,
Yes,
for example, if data is coming up from somewhere, controller manager decides where the data has to be stored, right?
yes,
So, as you said, if we have 60% data free space in Node 2 and 30 in Node 1, so what if the 61 stops working?
no, no, I didn't got your point. What did you said? Why?
I
Why
mean,
the 61
what
will work?
if node stop?
Okay, I got your point. What if
Yeah.
this node gets stopped, right? The server gets stopped.
Yes.
So that's a node failure. That means your node is down. That's a node failure. It's again a disaster situation.
Mm-hmm.
So what will happen in that situation? So if the controller manager gets the information that this node is getting failed or this node is not working, it's down, all the pods which are present in this node will be now saved automatically.
That means, are we saving same data in
No, no,
different
no.
nodes?
As I told you, we don't talk about the data when it comes about the data.
Mm-hmm.
We don't talk about the data. The data, which is like, we are talking about database, right?
Yeah.
We are in the database. You cannot launch the database in the no, Kubernetes. It's not a good idea to use the database in the Kubernetes cluster. Why? Because database we use to perform the operations in the database, and database contains lots of data.
Mm-hmm.
Lots of SQL operations goes there. So we
Yeah.
always deploy database on a separate server where we have a complete structure architecture for the database. The whole architecture works
Okay.
separately for the database. We have master, co-master in the database. We have slave nodes for the database separately. So database
Okay.
has a separate cluster. That's the reason because database data is a very important thing. And when it comes to the
Yeah.
applications, in that applications you can take the risk of the multiple nodes. Like you can keep your applications over there. If due to some issue the application is down, the application will be
Mm-hmm.
automatically deployed again. So there is a YAML basically that we use to write the structure of the deployment kinds and the kind of information. We provide that in a YAML format, and that YAML is deployed in this cluster. Okay.
Okay. So that means this architecture acts as a database only, right?
No, no, no. This concept for the database, you will have a separate cluster. For only database, you will have a complete separate cluster. Whole cluster will contain the data and the database program. This
So I
architecture
mean,
is
combination of nodes is a cluster, right?
exactly combination of nodes is a cluster. And when it comes to the Kubernetes, in the most of the cases, you will be deploying the application on the Kubernetes, not the database.
So here we are dealing with applications, not with the data, is it?
Exactly, exactly. Like you can
Okay.
deploy the database. It's not impossible, but it's not recommended because
Okay.
database is a sensitive thing. You have data stored. You cannot take risk on the database. But when it comes to the application, you have code on the GitHub. You have the artifact, the particular what we say images stored on the artifact tree. It pulls the image from
Yeah.
the artifact tree and deploy it directly to the worker node, right?
Yeah.
So this is how it works, and all configurations are managed in that particular YAML.
Okay, nice. Got it. Thank you.
So for more information, like you guys can go to this kubernetes.io. This is basically the documentation for the Kubernetes, and Kubernetes is developed by Google, by the way, but now it's not being controlled by Google completely. But yeah, when it comes to the Google has a service called GKE, Google Kubernetes Engine. It's a service which provides you the facility of cluster and lots of Kubernetes features in very smart way. Similarly, in AWS, we have EKS, again, Elastic Kubernetes Service, which is a very great thing. And in Azure, we have AKS, Azure Kubernetes Service. Okay, so there are multiple Kubernetes service. What do we do? These are managed Kubernetes service. Now here we talked about the cluster. There are two kinds of Kubernetes cluster or services. Number one is managed service, and second one is self-managed service. In self-managed service, you have to set up the cluster by your own, on premises or on cloud. You have to set up that by your own. And whenever you're using the managed service, in that they will set up the cluster for you. Every component will be installed over there for you. These master will be ready for you. The kubelet, kubeproxy, docker will be set it up for you. Okay, so this is the difference between like using a managed service and a self-managed service. In most of the cases, you will be using the managed services, but maybe if the organization is a very huge organization, then they can spend their money and time on the self-managed service as well, where they will ask you to set up the Kubernetes cluster. And setting up the cluster is very easy. You guys can check the commands and the tool structure from the blogs, right? How to set up Kubernetes. Like these are tools basically. For the practice purpose or the learning purpose, you guys can use the Minikube. It's a good tool that will set up a cluster on your one machine and will allow you to work on Kubernetes and practice the Kubernetes. The second is the QBDM. Basically, that's a tool that you can use for the production system that you will be using in the organization if you're working with the self-managed service. Okay, you can check out for these tools. And this is the official website of Kubernetes, and you can click on Kubernetes blogs. And also we have the what I will say documentation. Yeah, let's talk about the documentation. That's the most important thing. Understand Kubernetes, try Kubernetes, set up Kubernetes AKS cluster. QEDM is the tool, QADM, setup tool, learning environment, production environment, like this. Okay, all the tutorials are here for the Kubernetes. You guys can check out these tutorials and learn Kubernetes very easily. This is the concept of Kubernetes overview, architecture, security concept, lots of things are here. Okay, so kubernetes.io, this is the website and this is the docs page. I will share this URL with you in this chat, and as well as I will share the same URL in the classroom. All right, so that was all about the Kubernetes discussion. Now, if you guys have any doubts to anything that we discussed in this whole course, you guys can ask. Then we will be jumping on the resume samples. Anyone? Rajeshri, Adarsh?
I'm good as of now.
Okay. Rajeshri, all good? All right. So let's jump to the resume sample. So here, as you can see, I have one sample of resume. Now, this resume is not that great. So remember that your resume should not look like this. This was a one-page resume. First of all, everything depends on the level of experience. If you are a fresher, then your resume can look like this. And if you are 1 or 2 year experience, then never try to create a resume like this. Why? Because as you can see, this person is experienced like around 2 years of experience. But again, he does haven't mentioned the lot of detail here. And when it comes to the personal projects, there are projects like this, three-tier infrastructure. It's a very basic thing that you do on AWS, and few of the services are mentioned here. In skills, there is a very less number of skills. AWS services, the DevOps tools, versioning tools, operating system, that's it. Okay. And he also mentioned skill here. Nothing was written after that. So these are the mistakes. So basically, every organization there is a program for the resume selecting. They don't take all the resumes. Basically, if you are applying for the organization, you are not the only one who is applying for that particular post. There will be multiple people, right? Lots of people will be applying for that particular post. Now they basically shortlist on the basis of your resume. Now, your resume should not have any spelling mistake. The formatting should be done properly. The font should not be this much small, right? It should be a great looking resume. And it doesn't matter, your resume should be in PDF, PPT, even you can use the PPT. I have seen few resumes in PPT and they look absolutely great. It doesn't matter. But I will not suggest you because you guys are trying to for your career, so don't go with the PPT. But some people use that. If somebody is working as a web developer or a designer, then they showcase their resume as a PPT, right? It's a good way to express their designs, right? And you guys can use the Word documents as well. It's not like you have to send the resume only in that particular format. You guys can use the Word document, but never send a resume in an image. It should not be JPG or PNG, any kind of image. It should be in the particular document format. Okay. I have one more sample of resume. Now this resume looks very great because lots of things are explained here. Okay, lots of projects are here. But again, as you can see, there is a separate font is here. That means the person has edited the resume recently, and maybe there are lots of spelling mistakes in this resume. Okay, so here the person has explained the profile, the two types of profile that he was working, and the skill sets. As you can see, AWS Cloud, Linux, Bash, shell scripting, Jenkins, Docker, Kubernetes, Terraform, Ansible, Git, Bitbucket, and JForce, Nessus, Jira, Prometheus Monitoring, Tomcat, Maven. It's a great key skills, right? This is how you can explain your key skills. Experience, this is how they have mentioned the experience. And after this, projects, number of projects. Okay, this is also a project, roles and responsibilities. Even you can define your roles and responsibilities for separate projects as well. Like for example, if you have worked on 3 projects, every project will have separate roles and responsibilities. You can divide them into multiple sections as well. Okay, and also never write too much. Like again, even this resume is very like 3 to 4 pages, 3 pages of resume, but the person was 5 years experience. So yeah, this looks good. But still, as you can see, the first letter and there are few mistakes in this resume, so those mistakes should not be there. The font size and the margin and that kind of stuff. The formatting should be great. Rest of the things are just what you are writing. Nobody reads the resume like this. Like nobody is going to read this resume. What they are going to read is profile, experience, name of project, and few things related to project like technologies and your key skills. Nobody is going to read this whole text. Okay, so these were the tips for the resume creation. So always like be look professional in the terms of resume. Okay, because it's the first impression. And never, like, I won't suggest you to paste the photograph. It's just up to you. And if you want to do that, then again, yeah, you can paste the photograph as well. If you are experienced, then you can paste the photograph. And if you are a fresher, then it doesn't matter. Basically, you paste your photograph on your resume or not, it doesn't matter. But if you are experienced, then you should mention paste your photograph, and you should mention your LinkedIn profile, your GitHub URL, your GitHub repositories where you have done your projects. Those should be mentioned in your project in your resume. Okay. All right. That's all about the resume building. Okay. If you guys want to ask anything in this, go ahead. Anurag, Vinay, Rajashri, Adarsh, anyone?
No doubts from me.
Okay,
I have one question
okay.
uh, what we should know about the database like SQL and MySQL database? What is the DevOps understanding should be?
You should know the basic SQL commands. That's it. The basic
Like
SQL
the
command.
non-relational database like that?
Yes, you should know the basic SQL commands like how to fetch the data, how to check the data, how to get into the table and fetch the information, altering table, that kind of stuff. Only basic things, not in depth. You are not a DBA, you are a DevOps, so only basic things are required. DBA is a completely separate profile, and there are DBAs in the organization. And to set up a database cluster, again, remember that setting up a database cluster is the art of DevOps. And then setting up the communication, again creating networking, again is the art of DevOps. But setting up the database, installing database, and like creating data and putting and inserting data and creating database is not the part of DevOps. It's the part of DBA, database administrator. Okay, so you should know the basics and you should know the infra stuff. That's good. That's pretty much good. Nothing else is required. Okay,
Okay.
anything else, Rajashri? No. All right, then, guys, let's wrap up the session. So let me stop the